With flying cars looking more likely to become a reality, Hyundai Motor is jumping into the promising future industry. The South Korean car maker has appointed former NASA aeronautics researcher Shin Jae-won.
The future of transportation is taking flight, quite literally. Not one to be outdone, the Hyundai CEO has boldly stated that their new flying car will destroy the entire industry. This audacious claim signals not only a breakthrough in aerospace innovation, but also hints at a seismic shift in how we think about urban mobility. With advancements in electric vertical takeoff and landing or eVTOL technology, Hyundai's flying car promises to revolutionize the way we move, offering a glimpse into a future where traffic jams are a thing of the past and the skies are the new highways. As the race to dominate the air taxi market intensifies, Hyundai's entry is poised to disrupt everything we know about personal and commercial travel. This is going to be one thrilling rollercoaster ride, so buckle up and let's go. Hyundai's next-generation air taxis. They're calling it the Supernal, and it is making ambitious strides toward revolutionizing urban mobility with its electric vertical takeoff and landing or eVTOL technology. The Supernal SA2 is scheduled for commercial use by 2028. This development marks a significant evolution from its previous prototype, the SA1, first unveiled in collaboration with Uber Elevate back in 2020. However, unlike the overly optimistic timelines of its earlier ventures, where Uber aimed to initiate flight demos by 2020 and commence commercial rides in 2023, Supernal has recalibrated its approach, presenting a more grounded, albeit still highly innovative vision during CES 2024. The SA2 is an embodiment of Hyundai's ongoing commitment to advancing air mobility. With a 600-strong team at Supernal and the technological backing of Hyundai Motor Group, this aircraft signifies the company's deep investment in the future of air taxis. The team also taps into aviation expertise from global suppliers, which will be critical as they work towards securing FAA certification and testing their technology. So, is the Supernal SA2 going to be a game changer? Well, before we explore that, let's see why helicopters failed to make urban air mobility mainstream and how things are set to change. Why didn't helicopters become mainstream? The rise of urban air mobility has sparked conversations about the potential for helicopters to become a staple of city-based transportation. However, despite their pioneering role in aviation and their proven ability to transport passengers vertically in crowded or difficult-to-reach areas, helicopters have not achieved mainstream adoption. One of the most significant barriers to the mainstream adoption of helicopters is the high operational costs associated with their use. Helicopters are known for their expensive maintenance and fuel consumption, both of which make them a less attractive option compared to more cost-effective modes of transportation, such as cars and trains. Helicopters typically burn a substantial amount of fuel per hour, which can be far more expensive than conventional means of travel. Additionally, the maintenance required for helicopters is far more intensive than for other vehicles, with components needing frequent repairs or replacements due to the complex mechanics of rotor systems and engines. These factors contribute to the overall high price of helicopter travel, making it unaffordable for the average commuter or small-scale commercial operation. Moreover, helicopters lack the fuel efficiency seen in fixed-wing aircraft, which are able to travel longer distances at higher speeds without consuming as much fuel. This efficiency gap creates a significant hurdle in terms of the cost-effectiveness of helicopter transport, particularly for frequent urban commuting. While urban air mobility concepts, such as electric vertical takeoff and landing or eVTOL aircraft, promise to reduce energy consumption and operational costs through electric propulsion systems, helicopters' reliance on combustion engines remains a considerable disadvantage. Moreover, helicopters are notoriously loud due to the high speeds at which their rotors spin, which produces a significant amount of aerodynamic drag and engine noise. This noise can be disruptive, especially in urban environments, where high population density and residential buildings amplify sound. The constant noise created by helicopter flights, whether for commuter transport, news gathering, or emergency services, has led to complaints from communities, as it negatively impacts the quality of life for residents. While some advancements in helicopter design have aimed to reduce noise levels, such as quieter rotor blades and engine modifications, these improvements have been insufficient to make helicopters a truly viable and non-disruptive solution for regular urban transport. For context, even the quietest helicopters still produce noise levels that exceed the permissible thresholds for residential areas. As modern urban air mobility solutions emerge, quieter alternatives, such as eVTOL aircraft, are designed with multiple smaller rotors and advanced noise reduction technology to keep decibel levels lower, giving them an edge over helicopters in terms of environmental integration. Safety is another critical factor in the transportation industry, and helicopters, while significantly safer than many other modes of travel, have historically faced greater risks compared to commercial airliners or cars. Helicopter flights are more susceptible to weather conditions, such as strong winds, rain, and low visibility, which can make operations hazardous. Additionally, the complex mechanics involved in rotary wing aircraft increase the likelihood of mechanical failure. Helicopters are also more prone to accidents due to pilot error, which is exacerbated by the high level of skill required to operate them. While pilots undergo extensive training, the dynamics of flying a helicopter, especially in a dense, ever-changing urban landscape, present substantial risks. Additionally, rescue operations and emergency landings in densely populated areas can be more complicated than in rural or open-air settings. In contrast, the transition to autonomous flight in advanced urban air mobility vehicles, particularly in eVTOL designs, aims to mitigate these issues by incorporating redundant safety systems, artificial intelligence navigation, and real-time hazard detection. These innovations promise to make these modern solutions much safer, with automated flight systems reducing the potential for human error. The scalability of helicopters for mainstream urban transport is another significant challenge. While helicopters can effectively bypass traffic by taking off and landing vertically, their ability to scale for widespread use in dense urban environments is limited. The lack of sufficient infrastructure, such as heliports, takeoff and landing zones, and air traffic management systems, prevents helicopters from becoming an integral part of citywide transportation networks. Building the infrastructure required to support the extensive use of helicopters, including dedicated helipads on top of buildings or in crowded city centers, would be a logistical nightmare and expensive to implement on a large scale. Moreover, the limited availability of suitable sites for helicopter takeoff and landing in urban areas further complicates things. Helicopters are often confined to specific routes or require dedicated landing zones, limiting the ability to offer widespread service. For broader adoption of urban air mobility systems, cities would need to invest heavily in infrastructure development, which would likely be economically and spatially prohibitive in many locations. eVTOL aircraft offer a solution to this problem with compact designs, allowing for more flexible landing and takeoff operations at smaller sites. These vehicles are designed to operate from vertiports, smaller, more urban-friendly versions of heliports that can be placed in dense areas and integrated into the fabric of the city. This level of scalability, coupled with the higher frequency and broader geographic coverage possible with eVTOLs, makes them more feasible for urban air mobility. The environmental impact of helicopter operations has also been a factor in limiting their mainstream adoption. Helicopters rely on jet fuel, which produces harmful emissions, contributing to air pollution and carbon emissions. As cities around the world tighten their environmental regulations and seek to reduce their carbon footprints, the use of helicopters, especially for short-distance commutes, becomes increasingly incompatible with modern sustainability goals. In contrast, many modern urban air mobility concepts, particularly electric-powered eVTOLs, are designed with environmental sustainability in mind. These vehicles use electric motors that generate zero emissions, contributing to cleaner air and lessening the environmental impact of urban transport. As environmental standards tighten globally, eVTOLs and other electric air mobility solutions will likely become more attractive and viable alternatives to traditional helicopter transportation. But the idea of air taxis and urban air mobility is nothing new, and the timing for realizing this century-old dream is nothing short of immaculate. The history and future of air taxis. The first notable attempt to create a flying vehicle capable of both driving and flying came from Glenn Curtiss in 1917. Curtiss's autoplane sought to merge the worlds of automobiles and aviation by offering a vehicle with vertical takeoff and landing capabilities. This ambitious venture marked the beginning of a dream that countless inventors and innovators would try to make a reality, including figures like Henry Ford, Waldo Waterman, and Moulton Moult Taylor. However, despite their groundbreaking efforts, these early flying car prototypes were plagued by technical difficulties, accidents, and a lack of financial resources, which ultimately prevented them from becoming viable commercial products. Through the mid-20th century, the dream of air taxis continued to linger in the background. The 1950s through the 80s saw incremental advancements in aviation, though flying cars still seemed a far-off goal. During this period, helicopters emerged as the closest functional alternative to urban air mobility, serving select cities like New York, Los Angeles, and San Francisco. However, as noted earlier, they faced major obstacles that hampered widespread adoption. High operational costs, complex maintenance requirements, safety concerns, and environmental impacts such as noise pollution hindered the growth of helicopter services. As such, helicopters never fulfilled the promise of becoming an affordable, sustainable solution for everyday urban mobility. The real resurgence of air taxi technology began in the 2010s, fueled by advances in aviation technology and the rise of on-demand services. The advent of smartphone apps like Uber and services such as Uber Copter, which allowed passengers to book helicopter rides between Manhattan and JFK Airport, sparked renewed interest in air mobility. Companies such as Blade and Skyride followed suit, helping to popularize the use of helicopters for short-range urban transport. In parallel, agencies like NASA and the US Air Force launched key initiatives to improve the safety and scalability of urban air mobility systems, which laid the groundwork for the development of eVTOL aircraft, an innovation that offered a more sustainable alternative to traditional rotorcraft. The modern vision for air taxis revolves around the broader concept of advanced air mobility, or AAM, which is an ecosystem of aerial transportation systems that leverage cutting-edge technologies like electric propulsion, VTOL capabilities, and autonomous flight systems. The rise of eVTOL aircraft has the potential to revolutionize urban transportation by offering a quieter, more environmentally friendly alternative to helicopters. These vehicles aim to address several urban mobility challenges, such as traffic congestion, while reducing emissions and operating costs. As we approach the era of air taxis, the landscape is becoming more promising. Despite challenges such as regulatory barriers, airspace management, and the need for infrastructure development, the continued advancement of eVTOL technology and substantial investments are driving the industry toward a reality. These air taxis will be designed to serve a range of passenger needs, from single-passenger vehicles to larger, multi-passenger models that cater to diverse urban transportation demands. The adoption of air taxis is expected to reshape the way people think about transportation. With the development of eVTOL aircraft and autonomous flight systems, the transportation landscape is set to change dramatically. Air taxis will no longer be a distant vision, but a practical, scalable solution that could revolutionize how we move around cities, reducing congestion and offering faster, more efficient travel. Several design concepts have emerged for air taxis, each with unique features that cater to various needs. Electric propulsion is a hallmark of these designs, ensuring that air taxis are quieter, more energy efficient, and better suited for urban environments. The commercial potential of air taxis is vast. Analysts suggest that by 2025, up to 3,000 flying taxis could be in operation, with the number expected to rise exponentially by 2050. One of the key drivers of this demand is the need for faster, more efficient travel, particularly for trips that take over 30 minutes by car. In cities with large, affluent populations and heavy traffic, air taxis are poised to become an integral part of the transportation system. The development of verti-stops, which are dedicated vertical takeoff and landing zones, will be a critical component in the success of air taxis. These hubs will need to be strategically located in urban centers and transportation nodes, enabling air taxis to seamlessly integrate into the existing transportation infrastructure. However, the construction of vertistops will require overcoming logistical and regulatory hurdles. The success of air taxis also hinges on overcoming regulatory challenges, especially those concerning autonomy and airspace management. While the Federal Aviation Administration currently requires pilots on board, efforts are underway to enable fully autonomous air taxis that can operate without human intervention. These advancements promise to significantly reduce operational costs, enhance safety, and make air taxis more accessible to the general public. The future of air taxis is undeniably promising, with companies like Uber already planning to incorporate them into existing transportation networks. Well, this brings us to Hyundai's flying car. Hyundai's Supernal SA2 design concept. In January 2020, during the Consumer Electronics Show in Las Vegas, Hyundai Motor Company and Uber announced a strategic partnership to develop Uber Air taxis. This collaboration aimed at creating a new aerial ride-sharing network that would fundamentally transform the way people think about urban transportation. Alongside this announcement, Hyundai unveiled its full-scale concept mock-up of an eVTOL aircraft, named the SA1. Hyundai recognizes the challenges posed by increasing mega-urbanization around the world, where growing populations in cities have led to congested roads and diminished transportation efficiency. Hyundai's response to these challenges lies in its focus on urban air mobility, which promises to facilitate runway-free electric air travel within urban environments. Hyundai's Urban Air Mobility division, which was initially established as part of the company's broader future mobility vision, was rebranded to Supernal in November 2021. Supernal represents Hyundai's long-term investment in the future of urban air transport, with offices in key locations across the United States, including Washington, D.C., Fremont, and Irvine, California. The shift to Supernal underscores the company's dedication to advancing the eVTOL space, setting the stage for a future where urban air taxis and personal air vehicles are part of everyday life. The partnership with Uber plays a critical role in Hyundai's strategy to scale eVTOL production. Eric Allison, head of Uber Elevate, emphasized the significant potential that Hyundai brings to the table as a vehicle manufacturer with vast experience. Hyundai's ability to produce high-quality, reliable aircraft at mass production rates, unseen in the current aerospace industry, could be a game-changer for the future of air taxis. The integration of Uber's technology platform with Hyundai's manufacturing capabilities could drive down passenger costs per trip, making air mobility more accessible and creating the foundation for a thriving air taxi network in the near future. To support this vision, Hyundai has also assembled a human-centered city advisory group, comprising top global experts from diverse fields such as architecture, psychology, urban design, political science, and transportation. This advisory group has conducted extensive research on the future design of cities, with a particular focus on how urban environments can be optimized to support new forms of mobility. The research led to the identification of 3 core values for future cities: care, enable, and vitalize. These principles place a strong emphasis on creating cities that promote the well-being of their inhabitants, empower access to various modes of transport, and rejuvenate urban areas with sustainable, innovative solutions. The need for such transformation has never been more apparent, with mega-urbanization creating challenges for traditional transportation infrastructure. In response, Hyundai envisions a world where urban air mobility solutions become integral to city life. This brings us to the SA1 and SA2. The Supernal SA1 was first unveiled in 2020 as part of Hyundai's bold foray into urban air mobility in collaboration with Uber Elevate, marking a significant step toward making flying cars a reality. The SA1 was designed to operate as an air taxi, capable of carrying up to 4 passengers and a pilot for trips of up to 60 miles or 100 kilometers at speeds of up to 180 miles per hour or 290 kilometers per hour. The aircraft was entirely electric and designed for vertical takeoff and landing, making it suitable for urban environments. Its focus on sustainability, quiet operation, and advanced safety features aim to address the growing demand for innovative urban transport solutions in increasingly congested cities. The SA1 was a stepping stone in Hyundai's evolving vision for urban air mobility. It was more of a proof of concept than a fully realized commercial product. Over time, the company refined its vision and sought to develop a more advanced and commercially viable eVTOL design. The lessons learned from the SA1 prototype informed the development of subsequent models. In 2021, Hyundai launched Supernal, its subsidiary dedicated to urban air mobility and advanced air mobility. Supernal shifted focus toward creating a new generation of eVTOLs with better integration into urban ecosystems. This strategic pivot led to the development of next-generation aerial vehicles that address the limitations and challenges identified in the SA1 project. Then, in December 2020, Uber sold its Elevate division to Joby Aviation, shifting the collaborative landscape for Hyundai. This prompted the company to reconsider its approach and take greater control over its urban air mobility ambitions. And this brings us to the Supernal SA2. The SA2 combines the flexibility of passenger transport and air cargo into a single, versatile eVTOL concept design. This aircraft is engineered for adaptability, with an interior configuration that can be easily altered to accommodate either 2 passengers, 4 passengers, or a cargo layout, making it highly functional for diverse transportation needs. The passenger layout is designed to maximize comfort, with ample room for luggage, ensuring that it can effectively cater to urban commuters or short-haul air travel, as well as cargo transport. Initially, the SA2 will be piloted by a human operator, but the vision for the future involves a transition to autonomous operation, with artificial intelligence taking over the piloting duties to further streamline operations and reduce the need for human intervention. The aircraft has been designed to achieve a cruising speed of approximately 193 km per hour or 120 miles per hour, which is ideal for urban air mobility, where speed and time savings are paramount. The typical trip distance for the SA2 is expected to fall within the range of 39 to 64 kilometers or 25 to 40 miles, making it well suited for intercity travel or regional air cargo delivery. Its cruising altitude is forecasted to be around 457 meters or 1,500 feet, positioning it at an optimal level for avoiding congestion with conventional aircraft while remaining within the operational limits of urban airspace. The aircraft features an innovative powertrain consisting of 8 tilt propellers powered by 8 high-efficiency electric motors. This setup enables both vertical takeoff and landing capabilities and efficient forward flight. It is planned to be powered by high-voltage, fast-charging battery packs, providing the necessary energy density for its short to medium-range operations. The use of distributed electric propulsion, or DEP, not only enhances the aircraft's performance, but also contributes to its safety. This system distributes the propulsion across multiple motors, allowing the aircraft to maintain stability even if one or more motors fail. Additionally, the DEP system allows the flight computer to independently adjust the speed of each motor to ensure smooth and stable flight, even in gusty or turbulent conditions. In terms of noise performance, the Supernal SA2 stands out as an environmentally friendly option for urban air mobility. The noise level at hover is projected to be below 65 decibels, and at cruise speed, it is calculated to be under 45 decibels, significantly quieter than traditional helicopters or small aircraft. This reduction in noise pollution is achieved through the use of smaller, quieter motors and advanced rotor designs, making the aircraft more acceptable in noise-sensitive urban areas. These low noise levels are further aided by the aircraft's sleek design, which helps to minimize airframe noise during flight. The Supernal's windows, which are significantly larger than those found in conventional aircraft, are designed to offer exceptional views, enhancing the passenger experience during flight. Drawing inspiration from the world of biomimicry, the window's design takes cues from bees, specifically their compound eyes, which are not only efficient at gathering light, but also provide wide-angle views. The windows are designed to capture and amplify this feature, with their unique shape providing maximum visibility for passengers regardless of their seat position. The fuselage of the SA-2 is made from carbon fiber composite materials, chosen for their high strength-to-weight ratio. This construction method ensures the aircraft is both lightweight and durable, capable of withstanding the stresses of both vertical takeoff and landing and horizontal cruising. The overall design is focused on reducing the aircraft's light signature, ensuring that it can be easily identified in the sky by its distinct visual profile. This attention to aesthetic design, in addition to performance, ensures the SA-2 stands out in an increasingly crowded urban sky. To further reduce weight, the seat frames are constructed using minimal metal, leveraging materials that absorb energy during impacts, enhancing passenger safety. The tail assembly of the Supernal SA-2 features a V-tail configuration, which contributes to both the aerodynamics and structural efficiency of the aircraft. The aircraft also employs fixed tricycle landing gear, which offers stability during ground operations, and is designed to be simple yet effective, further contributing to the aircraft's overall lightweight and efficient design. These features work together to create an aircraft that is not only aesthetically appealing, but also highly functional in various operational scenarios. Safety is a primary concern in the design of the Supernal SA-2, which is why it incorporates multiple redundancy systems, particularly in its propulsion and critical subsystems. The distributed electric propulsion system, for example, allows for redundant motors to take over in case of a failure, ensuring the aircraft remains stable and can continue its flight. Additionally, the aircraft is certified for instrument flight rules, allowing it to operate in various weather conditions, even those with reduced visibility. For ultimate safety, the aircraft is equipped with a whole aircraft emergency ballistic parachute, a critical safety feature that would allow for the controlled descent of the entire vehicle in the event of an emergency. The aircraft will not only offer direct flights between urban centers, but will also be available through fleet services and maintenance packages, ensuring the aircraft remains operational and safe for widespread use. Hyundai's long-term vision includes full commercial availability of these aircraft, aiming for the beginning of serial production in 2028. Other than the aircraft, the S-Hub is a core component of Hyundai's urban air mobility ecosystem. These hubs will be designed with user convenience in mind, with indoor transfers ensuring comfort and protection from the weather. The one-story S-Hub will feature a roof-mounted landing pad for easy access to the Supernal aircraft, while the first floor will accommodate docking stations for the purpose-built vehicles, creating an easy transition from land to air. To support the passenger's journey, the basement levels of the S-Hub will include vital services such as restrooms, an emergency shelter, and warehouse spaces for storage. Additionally, the repair rooms will ensure the vehicles are always in top working condition, helping to keep operations running smoothly. The S-Hub Skyport takes this concept a step further, offering a multi-level facility that can accommodate not only passengers and vehicles, but also a larger fleet of aircraft. It will feature a rooftop landing pad for the Supernal eVTOLs, a passenger waiting area, and parking spaces for multiple aircraft. This high-capacity design will make it possible for large numbers of passengers to be transferred efficiently. The S-Hub Skyport will be strategically located in key urban centers, ensuring accessibility for passengers and optimizing the air traffic routes of the Supernal aircraft. In addition to the functionality and efficiency of these hubs, the design also emphasizes aesthetics, with the overall architecture aiming to integrate seamlessly into the urban environment. Together, the Supernal SA-2 eVTOL aircraft the purpose-built vehicles, and the S-hubs and skyports form the backbone of Hyundai's ambitious vision for a fully integrated urban air mobility ecosystem. Hyundai and its partners are poised to reshape urban mobility, offering a faster, more efficient, and environmentally friendly way to navigate modern cities. As production of the SA-2 aircraft begins in 2028, the future of urban air travel is set to soar to new heights. But wait, there's more. Hyundai's approach to sustainability in a changing transport market. As the world grapples with climate change and urbanization, Hyundai's vision for the future of mobility stretches far beyond traditional automobiles. Embracing electric vehicles, hydrogen-powered cars, and even aerial vehicles, Hyundai is positioning itself as a global player in the next-generation transportation ecosystem. At the heart of Hyundai's sustainability push is its dedication to electric vehicles. As one of the early pioneers in the global EV market, Hyundai has consistently sought to improve battery efficiency and reduce the environmental impact of its vehicles. The company's Ioniq sub-brand, which includes the Ioniq 5 and the Ioniq 6, showcases Hyundai's commitment to pushing the boundaries of EVs. By 2040, Hyundai aims to be carbon neutral, aligning with broader industry goals and international climate commitments. In tandem with its focus on EVs, Hyundai has doubled down on hydrogen-powered vehicles, positioning hydrogen as a key pillar of its sustainable future. The Hyundai Nexo, a fuel cell electric vehicle or FCEV, is one of the company's flagship models in this category, powered by hydrogen rather than electricity from batteries. This innovative approach not only offers zero emissions, but also ensures rapid refueling times and long-range capabilities, making hydrogen a potential game-changer for sectors like heavy-duty transport and long-distance travel. Hyundai's commitment to hydrogen fuel cell technology is not limited to passenger cars. The company has expanded its efforts to include hydrogen-powered trucks, buses, and even trains, further demonstrating the versatility of this green energy source. With increasing investment in hydrogen infrastructure and partnerships with key stakeholders in the energy sector, Hyundai aims to make hydrogen mainstream. Perhaps the most exciting aspect of Hyundai's sustainability vision is its push into aerial vehicles, particularly eVTOL aircraft. With the rapid growth of urban air mobility, Hyundai is leading the charge in developing flying cars that could transform city transportation. Hyundai's ambition in this space is clear, with plans to begin trials of its eVTOL technology in the coming years, with a goal to offer air taxi services by the 2030s. A key component of Hyundai's forward-thinking approach to sustainable transportation is its strategic partnerships with other industry leaders, municipalities, and research institutions. Recognizing that no single company can tackle the challenges of the future of mobility alone, Hyundai has built strong alliances across various sectors. This includes collaborations with tech companies to develop advanced autonomous driving systems, AI, and smart infrastructure solutions. Looking to the future, Hyundai's strategic vision is focused on a world where sustainable transportation is the norm, not the exception. With electric vehicles, hydrogen-powered cars, and eVTOL aircraft leading the charge, the company is transforming mobility in ways that were once the stuff of science fiction. By investing in innovative technologies, creating new partnerships, and supporting the necessary infrastructure, Hyundai is poised to be a major player in the global transition toward cleaner, more efficient transportation. Whether on the ground, in the air, or through advancements in infrastructure, Hyundai's multifaceted approach ensures that it will remain at the forefront of the sustainable mobility revolution. As cities grow and environmental concerns intensify, Hyundai's forward-looking strategy offers a glimpse into a more connected, efficient, and sustainable future. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.